This is section 5.5.1 on real numbers, understanding rational and irrational numbers. So in the previous lesson, we defined the rational numbers. They are the set of all numbers that can be expressed in the form of a over b, where a and b are integers and b does not equal 0. In other words, rational numbers are fractions. The integer a, or the top of the fraction, is called the numerator, and the integer b, or the bottom of the fraction, is called the denominator. And of course, here you can see some examples. All of these are fractions, including the number 7, because of course it can be written as 7 over 1. So they're all fractions, and they are all rational numbers. We've also talked about the subsets of the rational numbers. The natural numbers are the set of counting numbers. For example, 1, 2, 3, 4, 5, 6, all the way to infinity. Expanding on the set of natural numbers, we include 0. This set is called the whole numbers. It's the natural numbers and 0. Expanding on the whole numbers, we include the negative numbers. These create the integers, and they are the set consisting of the natural numbers, 0, and the negative of the natural numbers. Each of these subsets, natural numbers, whole numbers, and integers, are subsets of rational numbers because they can all be written as fractions. For example, 3 can be written as 3 over 1. 0 can be written as 0 over 1, but it's still 0. Negative 4 can be written as negative 4 over 1. So they can all be written in fraction form. Now the other part of the real numbers is the irrational numbers. The set of irrational numbers is the set of numbers whose decimal representations are neither terminating nor repeating. So we've talked about this, pi being the most popular irrational number. It's never terminating, never repeating. The number phi, which we're going to take a closer look at in the coming week, is also an irrational number, non-terminating, non-repeating. And the square root of 2. We've done a lot of work with square roots lately, simplifying square roots, adding and subtracting square roots, multiplying and dividing square roots. And in some cases, when the radicand, the number under the square root symbol, is not a perfect square, you have an irrational number. For example, it's the square root of 2. You can see the decimal form, 1.41421. It is a never terminating, never repeating decimal. So let's summarize the set of real numbers. Real numbers can be broken into rational numbers and irrational numbers. Within the set of rational numbers, we have the natural numbers, the integers, and the whole numbers. It's going to be very important that you can recognize which numbers belong to which sets. Meaning, if you're given a number, is it a rational number or an irrational number? If you're given a rational number, is it a natural number, an integer, or a whole number? Now, of course, if something is a natural number, it could also be an integer and a whole number. But if something is a whole number, it may or may not be a natural number or an integer. It's going to be very important that you understand the set of real numbers in great detail. Let's take a look at an example. All right, consider the set of numbers that is shown here. We have the numbers negative 17. We have the number negative 9/13, the number 0, the number 0.75, the square root of 2, the number pi, and finally the square root of 81. Okay, so consider this set of numbers, and we need to go through and we need to list the numbers from the set that are natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers. So you're going to see how some of these numbers belong to some of these sets, whereas other numbers belong to multiple sets. So let's go through and take a look at how we do this. All right, so we're going to start with part A. We need to find all the natural numbers. Now you remember that the set of natural numbers are the counting numbers. So let's go through our set of numbers. Is negative 17 a counting number? No, it is not. Negative 9/13, not a natural number. 0 is not a natural number. 0.75 is not a natural number. The square root of 2 is not a natural number. Pi is not a natural number. The square root of 81, this is an interesting one. At first glance, it does not appear to be a counting number, but hopefully you recognize 81 is a perfect square. And the square root of 81 is actually also the number 9. And 9 is most definitely a counting number. Therefore, it is a natural number. All right, let's go on to whole numbers. So, negative 17. Is negative 17 a whole number? You have to think back to the definition of whole numbers. Whole numbers are the natural numbers and 0. Well, that would mean that that's not a whole number. Negative 9/13 is not a whole number. 0 is a whole number. 0.75, not a whole number. Square root of 2, not a whole number. Pi, not a whole number. The number 9 is a whole number. So we have the square root of 81. And in fact, let me go back here because in part A I didn't want to write 9. I wanted to write the square root of 81. All right, that takes us to part C, the set of integers. So which of these are integers? All right, if you remember the definition of integers, the natural numbers plus 0 plus the negative of the natural numbers. So negative 17, that's going to work for us, right? So we have negative 17. Negative 9/13, not a natural, or not an integer. 0 is an integer. 0.75, not an integer. Square root of 2, not an integer. Pi, not an integer. Square root of 81, which is 9, definitely an integer. That brings us to the rational numbers. So these are fractions. Well, negative 17 is definitely a rational number because it can be written as negative 17/1. So we have negative 17. Negative 9/13, definitely a rational number. It's a fraction. 0, definitely a rational number. Can be written as 0/1. 0.75, we know that that can be written as 3/4. So yes, 0.75 is a rational number. Square root of 2. We know square root of 2 is a non-terminating, non-repeating decimal. Does not have a fraction form. That is not a rational number. Pi, not a rational number. And of course, square root of 81, as we keep saying, can be written as 9 or 9/1. So yes, indeed, it is a rational number. Part E, the irrational numbers. So we define irrational numbers as numbers whose decimal form are non-terminating and non-repeating. Well, that's not irrational. That's not irrational. That's not irrational. Not irrational. The square root of 2. If you type that into your calculator, you will see that it is a non-terminating, non-repeating decimal. and pi. We know pi is a non-terminating, non-repeating decimal. So those are the two irrational numbers in this set. And finally, part F, the set of real numbers. Well, from the previous slide, you noticed that the set of real numbers was at the top. Everything underneath it is a real number. So what that means is that every number in this set of numbers is a real number. So this is a good example. You can see that in many cases we have numbers like the square root of 81 is natural. It's also a whole number. It's also an integer. It's also a rational number. It's also a real number, right? And there are other examples here that also fall into multiple subsets of the set of real numbers. So again, it's going to be very important that you are able to identify numbers into certain subsets and understanding the set of real numbers. So this is section 5.5.1, real numbers, understanding rational and irrational numbers.